Hey guys, and welcome back to Concave Gaming. Today I'm going to show you how to turn a arcade board like this and put a Perspex kit like this to protect your arcade board. Now I'm gonna show you step by step on how to basically measure up some best practice techniques and how to basically design it from scratch in Adobe Illustrator. All the tips and tricks that you're going to learn are fully transferable, and you can pretty much design these for any arcade board. Now, why would you want to put arcade boards in this Perspex case? Well, first of all, it's for protection. A lot of the times arcade boards are stored like this. As you can see, they do bow a little bit, depends how you store them. So the best way to actually store arcade boards is vertically, and this Perspex is really good because it keeps the board level and protected, and yeah, it actually looks pretty nice, and you can get this done relatively cheaply. So in order to get started, what you really need is just a ruler, piece of paper and a pen, and sketch up the dimensions. So we can see that it's about 31 centimeters long times 23 centimeters. There is a hole in each corner, and there is also a hole somewhere close to the middle. Okay, now what you want to do is measure how much distance from the edge of a hole to the edge of a PCB, which is 3 mils. And 3 mils there, and the hole is actually 3 mils as well. It's a standard 3 mil M3 size. Okay, so I've already measured this up just to make things easier. So just start off with a drawing. So as mentioned, it's 31 across, 23 down, 3 mil hole with 3 mil on each side to the edge, and the middle hole is actually 12.5 centimeters from the edge as well. So once you have the dimensions, we can take that to Illustrator and proceed to the next step. You can also use a pair of calipers if you get some funny looking holes, just to double check the diameter if you wish, but most of the work can be done just with a piece of paper and a ruler. Okay, let's step over to the computer and fire up Adobe Illustrator. Okay guys, we have Adobe Illustrator running. So what you want to do is just click on a new file. Okay, in terms of a width, make it a little bit longer than the width of the design. So our width is 31, so make it 40, which is fine. Our height is 23. So what you want to do is make it 2.5 times the actual height, because you need 2 pieces, one for the bottom and one for the top. So 23 plus 23 is 50 plus a little bit more, so yeah, 40 and 70 is just fine centimeters, because we took the measurement in centimeters. RGB color and 300 ppi is fine. Okay, so just go create. Okay, so first what you want to do is just zoom in a little bit. Okay, and to begin with, what we want to do is just to basically sketch up the design. So first, just get a rectangular tool here from the left hand side and draw it up. Make sure there is no fill. Okay, so the width was 31 and the height was 23. Okay, we can start off at one point just to make it easier to draw, but later we can change it to something a little bit more universally accepted, right? So we're gonna click OK on that. Sorry, that didn't go through, so we'll do it again. So it's 31 and 23 and hit enter. Okay, so that in theory should be the shape of our actual PCB. Okay, so what do we know? We know that it's got 4 holes in each corner, the 3 mil M3 size, and they're 3 mil equally distant from each edge, right? So what we want to do is get another rectangle there. We make it the same width as the top, which is 31, and the height we want 0.3, which is 3 mil. So that gives us the gap dimension between the edge and the screw. So that's 1. I'm gonna copy and paste that again. Okay, and now we wanna do the same thing on the other side. And the height was 23. Okay. Good thing about Illustrator is that it actually snaps in with the shapes. So we do that. Again, we copy paste. Okay, and that gives us a 3 mil edge all the way around. Okay, so next thing we want to do is get our ellipse tool, create a little circle. You click on that and make that 0.3 and 0.3. Okay, and that gives you a 3 mil diameter, and you want to snap that into the corner. Copy paste, so Control C, Control V. Okay, do that again. Okay, so this gives us the board with 4 corners. Now we had 2 more holes near the middle, which were at 12.5. So the easiest way to do that, I found, is again get a rectangle tool. Okay, we're gonna make that width 12.5, and height we can make it again 3. Okay, and this will give us the distance from the edge to that screw point, so to that screw hole. Okay, which was at 12.5, and here if we copy the circle, okay, that will also interact and snap and be exactly 12.5, and you can see it's aligning with our screw holes as well. So this is essentially the exact drawing of Strikers 1945 2. But what we want to do is we don't actually want to make it exactly the same size. We want to make it a little bit bigger. So what we want to do is create another rectangle, but this time you want to make the size 1 centimeter larger in terms of width and height. So our width again was 31, so we're going to make that 32, and height was 23, so make that 24. Okay, so what will that do is give us a 5 mil edge all the way around, and that should snap in as well. Okay, and that looks good. Okay, now you go to highlight that rectangle, you go to FX, sterilize and round corners. Okay, and that will round off the corners nicely. Okay, so what you want to do now is go in, select the old rectangles that we did and delete them. And here we go. That should be a perfect cover for a PCB with a 5mm extra edge just to keep it protected. So what we want to do next is just select that and go Control C, Control V, because you want one for the top and one for the bottom. Right, and that's done. And just highlight all of it again. Okay, and you want to make sure there is no fill. Okay, and most places will accept a 1 point, but most will probably want a 0.1. So we can change it to 0.1. Okay, and now you go File, Save As, and just make it a EPS file and call it done. So I've already made one before, but I thought I'll make one from scratch. But yeah, if you send that to any laser cutting place or Perspex place, they'll be able to cut that up for you. Now, I recommend you get a few quotes and find a few places. Prices can vary. The more modern places with more marketing usually probably charge you quite a lot. So I am in Australia, and I had quotes for the two pieces ranging anywhere from $40 to $200. And the $200 were quotes where there was also some writing etched and things like that. That's why I don't do the writing etching on the PCBs. I just want the basic protection, which is bang for your buck. Especially if you're going to do a few arcade boards for your collection just to start them neatly. You want to basically, get the volume through at the lowest price point possible. So definitely get a few quotes. It's very easy to contact the sales department and just send them the design, ask them to give you one. So what we're gonna do is get that cut tomorrow, and when I see you guys next, I should have the pieces, and we can go over assembly and looking at the hardware and the fittings to put everything together. Okay, thanks guys. So we're cutting into the next day. We got the pieces cut here. In terms of the hardware, there is a couple of rules of thumb, I guess from my experience, because most of the time all the components are mounted on the top and nothing on the bottom. So most boards will use an 8mm hex brass female standoff between the bottom of the PCB and the actual bottom of the Perspex or acrylic sheet. Okay, so essentially you want to have an 8mm female brass standoff and M3 nylon washer. These are 8x1mm, and on the bottom I like to use a 8mm hex M3 screw. Okay, the top of a PCB you obviously have a washer on top. Then you have another male-female brass standoff, again in M3, that will go on top like that. And then the top acrylic will attach to that with 12mm screw from the top. Now, in terms of the top standoff, it really depends on the highest component that you have on the PCB. So on this PCB, the highest component is this large capacitor. So essentially what I'm using is a 30mm brass standoff. Some PCBs have higher components and lower components, so you might end up getting away with a 20mm or even a 40mm if you have bigger stuff in there. Okay, so next step what I'll do is I'll do the bottom and I'll cut back to the video. Okay guys, so I've took the cover off. I've attached the screws, the 8mm screws and the 8mm nuts, and got this ready for the PCB. So next thing will be mounting. What I found easier is to actually mount these from the top first and then screw them to the bottom. So let's do that next. Okay guys, we got this far. So obviously we have the PCB and we have the washers sandwiching the PCB just for protection. Okay, I also done a little bit different. So the holes in the middle, I've just put another 8mm screw in there, because we don't need to have so many standoffs, right? So only have the standoffs on the outer edges. So it's just something you might want to consider when designing your bottom and top piece in terms of how many holes you want. So you can actually have the top piece without the 2 holes here and just have the outer ones, but you still have the stability in the middle of the board so it doesn't warp and it's perfectly vertical. Sorry, horizontal. So let's put the top piece on now. Okay, so we're done. So obviously that's the bottom. That's the side view. And that's the top. It came out pretty good. So the most important thing is obviously the measurements, and just use the tips and tricks that I told you guys before. Obviously, as mentioned before, adjust your height of your hex standoffs based on the tallest component, so there's still a little bit of clearance there, and that would vary from board to board. Most boards will be okay for a 30mm, some even go slimmer, but 30mm is good. So 30 and 8 is a good rule of thumb, and obviously buy enough of this stuff. Now, I won't provide any links to these parts on AliExpress because the links would expire and they probably will not be valid in 6 months time. But if, like I mentioned, if you just go to AliExpress or eBay and you search for M3 brass hex standoffs in whatever size, 8, 30, 40, 20, 15, the M3 nylon washers, which are plastic, these are 8 times 1 millimeter, and you're gonna have the 8 mil and the 12 mil screws as well, which is in M3 as well. I use the 8 mil on the bottom and the 12 mil from the top, because obviously the top bit is always bigger. So yeah, that's the stuff I use. The bottom one is always a female, and this one is always a male-female brass standoff, providing you have a 1-layer board. If you have multiple layer boards, you might obviously need to adjust or have a triple stack in terms of the standoffs, but you know, you get the idea. But overall is good. In terms of the acrylic or plexi, I get this cut in 4.5 mil. That's the clear that the supplier that I use has. He doesn't have 4, and he's got 3. So 3 mil is a little bit too thin, but a 4 or a 4.5 is actually really nice and sturdy, as you guys can see. So I hope this is useful for you guys. If you like it, please give it a like, subscribe to the channel, and follow for more content. I'm also planning to do a little bit more advanced guide on something like a Mortal Kombat midway board, which has 2 PCBs. And if you guys would like to see that, just let me know in the comments below, and I'll create a video on how to make a midway plexi cover for a more advanced sort of PCB design. Thanks guys.